In episode 28, titled Compile Asset and Software Inventories, we kick off by building a practical case for reliable inventories that support security, operations, and compliance without turning into busy work. An inventory is more than a spreadsheet. It is the canonical description of what exists, where it runs, who owns it, and how critical it is to the mission. When inventories are trustworthy, downstream processes like vulnerability management, incident response, and continuity planning stop guessing and start executing. The payoff is measured in fewer surprises, faster fixes, and clearer accountability. The initial goal is modest but powerful, a living register that engineers believe, managers fund, and assessors can sample without hitting dead ends. Scope makes or breaks the effort, so define it broadly enough to reflect reality and narrowly enough to execute. The inventory should include traditional hosts, virtual machines, and on-premises appliances, but it must also account for containers orchestrated at scale, ephemeral workloads spun up by pipelines, managed services consumed from cloud providers, and serverless functions that exist as code plus configuration. Describing scope in these terms reframes the task from machines to computing surfaces, which better matches modern environments. For each surface, the inventory should capture how it is provisioned, how it is addressed, and how it is decommissioned. By writing the scope line once and sticking to it, teams prevent perennial arguments about what counts and keep attention on coverage and quality. Strong inventories begin with strong identifiers and context, not just names. Each record should carry a durable identifier, a human-readable name, a declared owner with a reachable contact path, the environment designation, such as development, staging, or production, the tags that systems use for routing and policy, and a criticality rating tied to business impact. Owners must be roles backed by people, not mailing lists with no one home after hours. Tags should be mandatory and minimal, focused on ownership, application, data classification, and environment, so that policies can be expressed as code. Criticality ratings should connect to recovery objectives and service level expectations, which converts the inventory from a static list into a decision system. When these fields are complete and current, everything else, alerts, reports, approvals, works more smoothly. Software needs equal precision because vulnerabilities and licenses track to versions, not intentions. Each asset should list installed and running software with versions, publishers, license types, and counts, deployment methods such as packages, images, or containers, and provenance that explains where artifacts originated. Provenance is the insurance policy against supply chain surprises. If you know whether an artifact came from a trusted registry, an internal build pipeline, or a one-off download, you can prioritize risk and remediation. Recording deployment methods matters because patching a package is not the same as replacing a container image or rolling a function version. By tying software entries to the assets that execute them and the repositories that store them, the inventory becomes a map for both security and operations. Automation is the heartbeat that keeps inventories from drifting. Cloud application programming interfaces, APIs, and configuration management platforms can enumerate resources, capture metadata, and detect changes far faster and more consistently than manual surveys. Discovery jobs should run on a cadence measured in minutes or hours for dynamic platforms and days for slower-moving systems with results written to a single source of truth. Configuration management agents and orchestrators can publish host facts, package lists, and service states, while container platforms and serverless frameworks can advertise running images and function versions. The goal is coverage first and enrichment second. Get everything into the system, then add detail fields that power reporting and control. Automation reduces finger-pointing because the data come from the platforms themselves. Multiple feeds create a new problem. Different names for the same thing. Normalization and deduplication stitch the inventory into a coherent whole by reconciling identifiers across cloud accounts, hypervisors, orchestration layers, and configuration tools. Matching rules should prefer immutable identifiers like provider resource IDs, machine serials, or image digests, with human names treated as aliases that change over time. Where uncertainty remains, the system should flag candidates for human review with clear comparison fields. Normalization also standardizes tag keys and values so that prod, production, and PRD do not fracture policy. When deduplication is enforced automatically and reviewed routinely, reports stop arguing with each other and controls apply predictably. Shadow assets are the hazard hiding in plain sight, untagged, unmanaged, and often insecure. These may appear as development sandboxes spun up with personal credit cards, forgotten test systems left outside patch cycles, or unmanaged Internet of Things devices plugged into quiet corners. Shadow software exists too, unauthorized agents, side-loaded tools, or abandoned services that still start at boot. The inventory should include a detection program that looks for anomalies in network flows, identity logs, cloud bills, and vulnerability scans to surface assets that never announce themselves. Treat each discovery as both a fix and a lesson, updating guardrails to prevent the next shadow from forming. Ignorance is not bliss here, it is risk with a timer. A simple, high-leverage boost is to require tags at provisioning, with ownership among the non-negotiable keys. Enforce this in infrastructure as code templates, request portals, and self-service pipelines so that resources without required tags never make it to running. For platforms that allow post-creation editing, use policy engines to evaluate resources continuously and quarantine or terminate those that fall out of compliance after a grace period. Ownership tags should point to accountable roles, and automated notifications should reach those owners when scans fail or costs spike. This practice does not add bureaucracy, it adds traceability, which reduces mean time to fix and improves audit confidence. Inventories become operationally valuable when assets are linked to the applications they support, the data stores they touch, and the external dependencies they rely on. Application mapping shows which hosts, containers, and services make up a system so that responders understand blast radius and change planners understand coordination. Data links indicate whether an asset stores regulated information, reads from a sensitive repository, or exposes a public interface, which drives priority and control selection. External dependencies, identity providers, payment gateways, message brokers, third-party APIs should be recorded with contracts and contact points so that incidents affecting partners can be triaged without phishing expeditions. These relationships turn the inventory into a living architecture diagram that helps both engineers and assessors. Security programs depend on inventories that talk to scanners, patch tools, and baseline checkers. Feed assets to vulnerability scanners with the right credentials and scopes so results map cleanly back to records. Patch orchestration can then target groups by tag and criticality. Configuration baselines, whether expressed as hardened images or policy rules, should be attached to asset classes with compliance status reported in the same place people read ownership and version data. When a new host appears, it should be scanned, baselined, and patched by default because the inventory triggers those flows automatically. This closes the loop between know what you have and keep what you have within guardrails. A mini-review cadence keeps quality high without slowing teams down. Coverage asks whether anything is missing relative to cloud API counts, virtualization platforms, and license trackers. Ownership checks that every record has an accountable role and active contact path. Automation confirms that discovery jobs ran, succeeded, and updated fields recently enough to trust. Reporting verifies that stakeholders receive the slices they need by application, by environment, by criticality, with trends rather than snapshots. Traceability ensures that each record can be followed from creation to retirement with dates, approvals, and evidence. 5 questions, asked regularly, turn the inventory from a project into a product. Retiring a legacy host offers a practical scenario to illustrate discipline. When a decommission request is approved, the asset record should move through a defined state machine. Stop workloads, detach from load balancers, snapshot if policy requires, wipe according to standards, revoke credentials and secrets, remove from scanners and monitoring, and update dependency maps. The inventory should record each step's timestamp and actor. Then, mark the record as retired with references to change requests and destruction certificates if applicable. Orphaned DNS entries, dangling firewall rules, and stale credentials are common leftovers. Linking decommission checklists to the inventory prevents those ghosts from haunting the environment later. A short anchor phrase helps teams remember the habit without a lecture. Find it, tag it, track it. Find it means discover continuously using platform signals, not quarterly hunts. Tag it means add ownership and minimal policy labels at creation so controls can attach. Track it means keep states, versions, and relationships current so reports, scanners, and responders can act without guessing. This compact line fits easily into onboarding, pull request templates, and change review meetings, and it builds a shared language across operations, security, and compliance. Finally, stabilization turns into governance when inventories drive compliance checks automatically. Configure policies that flag assets without owners, software without provenance, workloads outside supported regions, or resources missing required baselines, and route those findings to owners with due dates. Publish coverage and freshness metrics so leaders see progress and exceptions. The next action is concrete. Enable compliance checks tied to your inventory and verify they create tickets or alerts that close. When the inventory becomes both the map and the engine for controls, it stops being a document and becomes an operating system for your environment. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.